Hello everybody. So today we'll be studying about alkynes. This lecture will be useful for you for class 11 students who are having this in your school examinations along with Neet and JE students. So let us start with the preparation of alkynes. So as we already know, alkynes are unsaturated hydrocarbon. So you can see over here in the diagram of alkyne, if you notice there are three bonds. If there are three bonds, that means there is one sigma bond and two pi bonds. I hope you all are aware of these things earlier, correct? So we proceed with how to prepare alkynes. First method that we are going to discuss today is dehydrohalogenation. This method might be familiar with all of you while studying in class 10th also. While preparation of alkenes has already been done, this method has already been used. Here we are using a vicinal dihalide. Question is, what is vicinal dihalide? Vicinal dihalides are the dihalides where halogen atoms are attached to carbons which are adjacent to one another. Like we can see over here, this halogen is attached to this carbon and the adjacent carbon has another halogen. This type of dihalides are called vicinal dihalides. In this vicinal dihalide, we have taken alcoholic KOH. Alcoholic KOH promotes elimination reaction. Wherein the halogen from one carbon and hydrogen from the adjacent carbon will be eliminated and we will be getting a double bond over here. Here the elimination is anti-elimination. That means if the X or the halogen taken from one side of the carbon, from the other carbon the hydrogen will be taken from the opposite side. So as soon as this double bond is formed, after that many places we may have learned that alcoholic KOH again can be used to get our alkyne. However, that is not true. Why? Because there is a double bond, single bond and lone pair which will cause resonance. And due to this resonance, there will be a partial double bond character in carbon halogen. So there will be partial double bond character in carbon and halogen. And this partial double bond character is very difficult to break. And for that we need special reagent, sodium amide, that is NaNH2 in liquid ammonia. The temperature will be 196 Kelvin. In this you are going to get NH2 minus ion. This is very good nucleophile. I hope you guys are familiar with the term nucleophile. Nucleophile is very much necessary over here to eliminate hydrogen and halogen from the reaction. I hope you guys have gone through the elimination reactions E1 and E2 both, so that it can help you to understand this kind of reaction mechanisms. So while we give NaNH2, the reaction is similar. There is one X which is removed, there is one hydrogen which is also removed. Anti-elimination takes place and results in triple bonded alkyne. The total reaction can also be done with only giving NaNH2 in liquid ammonia. But very often it's done in two stages. In the first stage, alcoholic KOH is used and in the second stage NaNH2 is used in liquid ammonia. Temperature is 196 Kelvin. Requirement of a better nucleophile is the cause for using sodamide or sodium amide. If you have understood this concept explained in dehydrohalogenation, you should be able to do this kind of problems also. If you see this one, this halide, that is dihalide, here the halogen is attached to the same carbon. In both these compounds, halogen is attached to the same carbon. So if halogen is attached to the same carbon, that means they are called geminal dihalides. I hope this is clear to each and every one of you. Now after this, you need not think whether there will be different kind of reaction for geminal dihalides. No, it will be similar kind of reaction for geminal dihalides also, as we have gone through the normal dehydrohalogenation. So you guys need to complete this practice by pausing the video for say approximately 2 to 3 minutes, and after that I am going to give you the solution which you are going to check at your end. So now I am giving the solution of this problem. This will result in simple ethine or acetylene. One Br from this side and one H first time it will go. Next another Br and another H will go from the left hand side carbon in the second stage. So it will result in alkyne, that is acetylene 2 carbon alkynes. In the next question, here also similarly R will be remaining, 2 hydrogens will go, 2 Br will go. So it will result in a higher alkyne due to presence of this alkyl group. I hope the problems are clear to you and all of you have been able to solve this earlier only before my answer. Coming to another part, that is another part of practice. So again you solve these two questions by yourself and just check the answer from my end. Pause the video for 2 to 3 minutes. I am solving it now. This will be the result, and in this one this is simple addition reaction of bromine opening the bond. Now you have got dihalide. So first one of the bromine will go and there will be a formation of a single halogen substituted alkene. Next, second step, it is important to give NaNH2 because there is a resonance taking place over here, due to which there is a partial double bond character between this carbon and bromine atom. Now when NaNH2 is given, definitely this bromine is going to get eliminated and will result in alkyne, simple alkyne. I hope again you have been able to solve the problem before my answer. I hope now we can go to our second method of preparation, and each and every one are in complete focus with me. Here we are going to do dehalogenation of tetrahalides, another very simple and important method for preparation of alkynes. So here you see, here it is tetrahalide. Here it is tetrahalides. In this tetrahalide I have taken this one. When you give zinc dust in presence of alcohol and heat it, zinc takes care of the chlorines. Zinc takes care of the chlorines. As you have to remove 4 chlorines over here, so you have to give 2 zinc atoms for balancing purpose. So 2 molecules of ZnCl2 comes out, and the rest part you can write just as it is and increase the number of bonds between the carbon, because if you see, as soon as you take all the chlorine, the structure is like this. Now this carbon is still having only 2 bonds, so you have to increase the number of bonds to get the product. Done. Next, again another practice, similar type of questions. So definitely you will be able to do it. Stop the video for just 1 minute, don't stop, pause it and then check the answer. Now I am solving it. This will be the answer. It is but to ine. I hope all of you have been able to do it. No, I am sure you have been able to do it. Now, our next method of preparation is from iodoform. First question should arise in your mind, what is iodoform? Iodoform is CHI3. It's a yellow color precipitate. Very often it will be used as a test methodology for identification of various kinds of organic compounds. So iodoform reaction is very important. That's why I have marked star over here. How does this reaction takes place? Here you have to give silver dust and heat. What happens? This silver takes care of all the iodine. So there will be formation of 6 AgI, and the other hydrocarbon part of it gets joined with a triple bond. Very simple reaction, box type, no issues. I think everything is clear. So it's very simple. Now we move to coal-based electrolysis. So before moving into coal-based electrolysis, let us revise a bit. In geometrical isomerism, you have studied about these two compounds, malic acid and fumaric acid. One of them is cis, another is trans, which will be used in the preparation of alkynes now. I have taken the cis isomer. You can take the trans isomer also. There is no problem. So if we give KOH to this malic acid, then what happens? It will be a normal neutralization reaction, correct? So in this neutralization reaction, definitely salt is going to get formed. So this base is going to leave out this OH minus, and definitely the acid is going to leave H plus. So two molecules of KOH is going to do the job for us. So this OH minus is going to combine with H plus to form water, and COO minus is going to get combined with K plus, resulting in potassium maleate. Here this is the substrate for electrolysis. As soon as you put this potassium maleate in water, this is going to ionize just like this, correct? And water is also going to ionize just like this. So I am going to get maleate ion. I am going to get maleate ion and potassium ion and H plus and OH minus. As we got maleate ion, we also got OH minus ion. Now we will go to anode. Anode is going to accept the maleate ion. Maleate ion is basically having ease of discharge with respect to the OH minus ion. Maleate ion will lose 2 electrons to form this. It is an uncharged one. Now to attain stability, it is going to decarboxylate. That is, it is going to release 2 molecules of CO2 and is going to give you alkyne as it is. What will happen at cathode? We should do that also. In cathode, if you see what are the ions formed, ions is K plus and H plus. Definitely H plus is going to get discharged fast. So at cathode, H plus accepts 1 electron, forms hydrogen atom, and then to attain stability, the hydrogen atom, 2 of the hydrogen atom combines to form H2 molecule. That is it, formation of H2 and formation of alkyne. For your practice, once again another problem over here. So pause the video for 2 minutes and try the problem, do the complete electrolysis, find out the hydrocarbon product. I hope everyone has done it. Now I am going to show. First, the sodium salt of acid will be formed, and then after the complete electrolysis process, the hydrocarbon product in this time will be this one. If you want a shortcut, I'll just let you know. Just this over triple bond. This is again but2ine. Clear to everybody? Now we'll be going for our next method of preparation. This is laboratory method or also can be used for manufacture. So I have mixed the laboratory method and manufacturing process. In laboratory, you are not going to bring calcium carbonate. However, in manufacturing, you are going to bring calcium carbonate as a raw material to your factory. And in that factory or industry, whatever you have, you are going to heat this calcium carbonate at 1275 Kelvin, which is approximately 1000 degrees Celsius, to form CaO and CO2. What is CaO? CaO is quicklime, and that after that you are going to add carbon to it or coke, and at 2275 Kelvin, that is approximately 2000 degrees Celsius, it is going to give you calcium carbide, which is very commonly called calcium carbide, but chemically it is calcium ethynide. This is the formula, actual formula, the structure of calcium ethynide and CO, very commonly often termed as calcium carbide. Now with this calcium carbide is basically ionic carbide, and with this we are going to hydrolysis it. What do you mean by hydrolysis? Addition of water. Water means H plus OH minus. So from this, the OH minus is going to go to calcium hydroxide, and the two hydrogen atom is going to go H plus, so it is going to form HC triple bond CH. A shortcut method is outlined here. You can also copy this by pausing the video. I hope each and everyone is getting to understand the tricks and threads of organic chemistry. Going to the next topic. Now, in this laboratory preparation or manufacture, there will be some impurities. These impurities are generally hydrogen sulfide and phosphine. The name is phosphine. pH3 is phosphine, NH3 is ammonia, and there is also another one, that is ASH3, which is not the impurity over here. It is called arsine. Clear? Okay. Now, how it is removed? It is removed by adding copper sulfate solution. Once you add copper sulfate solution to this, then what happens? Copper sulfate solution reacts with it. Double displacement reaction, formation of copper sulfide, which is a black precipitate, which can be easily removed. Similarly, in case of phosphine, we are going to get copper phosphide. Okay. So you can ask whether it is cupric or cuprous. Definitely it's cupric, because here it is copper 2 plus. So cupric phosphide, cupric sulfide. No issues. Black precipitate again can be easily separated out as it is a precipitate. C2H2, which is alkyne, the basic product that we are fighting for, is collected by downward displacement of water, because very simple, it's lighter than water, guys. Why not air? It can burn in air. Now I have given you some practice homework. Within that, I have already solved these two. These two are also other manufacturing process of alkynes or ethyne. Okay. However, this is very nice to work out. So if you cannot do this, I have also done this for you. So what I have done is Mg2C3, I have broken this. That means this is an ionic carbide. So it is 2Mg2 plus, and this is the C3 part. So this is, again, if you see this ion, you can say this as propionide. It is a propionide ion. Okay. So it has 4 minus, 3 minus, another minus. So this is total 4 minus. When water comes towards it, the 4H plus is going to combine with this, and 4OH minus is going to combine with this to give you 2 MgOH whole twice, and here we will be getting our propine. If you see this, you can easily identify and come out to the answer. I think that is all about the preparation of alkynes. I hope each and everyone have thoroughly enjoyed the lecture and have noted down everything, because ultimately it's your life, your choice. With that, thank you very much. Good night.